¿Qué tal? ¿Cómo estáis? Bueno.
Good morning, everyone. Welcome back to the second session on CyberCamp 2018. We're so happy with the success of our workshop. Thank you to all the speakers that have taken the floor this and will take the floor this few days. Before introducing you to the speaker, I remind you that you can go to the social media. You can use Twitter at CyberCamp ES, and the hashtag is CyberCamp18. So I encourage you all to go there and share everything, comments and pictures and everything else. Here we have Javier Banco Rubio, who is the academic head of the Communix group, and he will be the one sharing this seminar on total system control, a game for lammers. Hello. First of all, thank you for your attendance. I know there's many people who couldn't make it, so CyberCamp in Malaga is quite a hit. Thank you, INCIBE, for throwing it here, and also the Palo de Contenidos for the venue they offered. So my index is short: theory and practice. A short theory and then practice. This is a seminar and not a lecture, and so everyone, even from scratch, even if you're in high school, you can learn basic things and then move forward step by step and promote this awareness about cybersecurity. My name is Javier Blanco. I'm the academic head of Communix, an ethical hacking school. And I'm also part of a cybersecurity company where I work as a consultant. I created this company because I already had some hacking websites, and we were hacked. We were doing something else in the past, but we were hacked by a guy from Algeria. He was a 16-year-old. And so what I want to do is to raise awareness. It's not a technical workshop, but people need to know that it is easy to be hacked and very difficult to securize your systems. So first, let's explain what we will do. We have basic concepts. We all know ASCII, which are the digits that we enter through the keyboard. We have the decimal system, which is base is 10. Then computer system use binary system, O's and 1s. And then hexadecimal system. That's important for the hacking world. The hexadecimal has a basis that is 16, 0 to 9, and 8 through F. So, we'll see it is very much needed to work in the field of cybersecurity. Malware. It is a widespread concept. Any malicious code, so any software that attacks a user without permission is considered malicious or malware. What else can we find on regarding these topics? The assembler, which is the machine language that is used for the programming of microprocessors. Very complicated, old actually, and it started with Unix, and then it turned into higher languages such as C and Linux that we have now. We have also a debugger with Google to see the bugs in a program, then bypassing, where we try to evade systems, whether they are firewall or antivirus. And here, when we talk about nukes, we have on the right side a technique to bypass any security system, framework or metaexploit for hacking, and then the loop that is characters, that's an NOP, empty characters, so that you skip it. If you find a nope, it moves on to the next one in the programming. Antivirus. So if we want to infect a computer, that's what we try to evade. If not 95% or even more than those computers have a free antivirus software. They follow heuristics, which are algorithms trying to understand what action we will take in order to detect it as a virus, and then signatures, which are hexadecimal, which is a hexadecimal code that is repeated. If I have malware or ransomware such as Cryptologic or others, we try and find what sequence is repeated through the code, within several infected devices. We see the signatures nature, but these are just hexadecimal characters. So for an antivirus, we need reverse engineering, so starting with a virus or a computer that is infected, and going backwards, we will see what's the behavior of the virus, the hardware, whatever. This is known as reverse engineering. Then we have sandboxes, which are control and simulated areas where we have several virtual operating systems to try out a malware or a virus of any kind and see what functions are being performed. If it is ports being open or redirecting traffic to a site. Binding, that's important. We get a file or that can be implemented and run another file masked. What I mean is you open a program, install it, and it's happened to us probably when we don't know. So we download a program for a website and we actually run a virus in the background. So you can have full control of a computer just by running a apparently safe program. Then we have joiners, where we produce a second executable file. Then we have builders. We will use a few. Then stop. This is a file that encapsulates another file that has been encrypted, usually the virus trying to have it decompressed on the EOF and a file. That's what it stands for. So what features will we try to find when we develop any kind of malware is persistence, the ability to keep the malware in a system, whether through retroviruses, so attacking the antivirus itself, so to close up the process, obfuscation, that is what we use to modify the code. So any programmer or anyone who sees that, whether through reverse engineering or any other way, they don't learn about the code. So we conceal what the malware is doing. Then the backdoor, so if I infect a device, I will not need to infect it every time I want to go in there. So I built a backdoor and I will have access without having to reinfect it. The FUD, fully undetectable. This is any malware that has not been found by an antivirus, or the fear number possible, the lower number possible. Types of malware. Set files, but now we move on to malware because it's changed the kind of negative effect on a system. We have a malware for misleading advertising, then clickers. If we have an ad send, we see other IPs from other devices, ransomware or locker that we've seen on the media, such as Cryptologic and others. Spyware, also the same, to spy on credentials and move information out of the user. Worms, so any kind of malware that tries to replicate itself and move around a network through different devices. Phishing, you've all heard about it because you got emails probably to get your credentials for a bank or whatever. Then Trojan would be any virus that has been run by the user. Malware is a specific damage for a user. And then we have the keylogger, which is very interesting. And this is an app that will register everything that is keyed or entered by the user on the keyboard. So everything that it is entered, we will know. Then RAT. Anyone has used a rat before? Only a few. And what about TeamViewer? It is a Trojan horse. It is actually a remote access Trojan. So if we want to infect, you cannot say show TeamViewer and give us the credentials. We will be using rat, so that we can have control over a device without the victim knowing. Then we have the rootkits, a whole set of applications that we don't know what they are used for, but we can use them for a botnet or spam or DOS, whatever. I said short theory. All right. So let's move on to practice. There is a veteran here who said, well, disclaimer, I'm not responsible for the knowledge here. Actually, This is for the dissemination of cybersecurity, understanding how easy it can be to get a device infected. I got my cheat sheet here. Let's start with Windows systems, the easiest ones. So these are two operating systems virtualized. Both are Windows 7. This is the victim, and this is the attacker. First of all, we will go to the annotator. You can download them for free on the internet. It's not complicated, no need to know anything. That's why it is for lammers, because a lammer is the hacker or so-called self-called hacker, and just by pushing next, they can hack a system, and it's easy. So if I open the annotator, they will say that this is a functional offset. And here I have a new line with the name of the file. So this is considered a virus by antivirus programs. If I use Avast that I've updated today, we realize it is, or it seems to be, a virus. It is not dangerous, but it is running and saving things on the system. The offset locator will help us encrypt if I want to evade an antivirus. First, the content of the antivirus or app that can be potentially dangerous, I will encrypt the content or part of the content for the antivirus not to get the signature. So I need to have the signature of the destination antivirus, Avast here, but I could use it for different things. So I need to have an FUD, a virus or an exe file that cannot be deciphered or decrypted. Offset annotator has to be registered, so OCX library. You cannot see, right, too many pixels here, right? Is it any better? No, it is not. So it won't work for us, but still, in natural screens, it'll be better. With Offset Locator, which is a builder, and this is an app or a graphical environment where we will build our virus. We try to find an FUD. So we choose the file we want to encrypt. So Offset Annotator, I tag it. And so it asks for the output directory. It produces a series of signatures to see if I can evade the antivirus signatures. I just build a new folder, signature, for example. So every offset possibility, we'll see what it is, will go in here. So signatures here. We have the offset concept, which is actually a jump, a leap in the memory. I want to have the exe file or the virus in full. I will use the initial point all the way to the final one, so it will get all everything, the program and every potential signature, every 1,000 bytes, for example, as we see here. It will be segmented, and we will have several variations, changing for a value such as fill in with zeros. Let's say 100 bytes for the test, and then we will say, what about the DLL, for example, this builder, or a .exe. I will go with .exe, and then we click on run. Now we have several signatures, and problem is many will be detectable and executable. It depends on what I've changed. For me to know what's a virus and what's not, I can run this on every field and folder and hope that with these parameters can give us something that is not found by the antivirus. This is a crypt where I cipher part of the content where the signature is, so that it doesn't detect that it is a virus. Depending on the software, it takes longer or shorter, but well, I took this one. This is a short one. It should be, at least. All right. You'll see that there many are wrong. And so the antivirus will move away or take away all the offsets, or the signature files on the annotator, it will remove those. But some are present. These are virus-free, at least for Avast antivirus. Some does work, some do work, some don't. So we just need to see which ones open, and we see this works right. And if you just press accept, I have a functional offset, and this is the signature. Just with one, we'll see this is the case, and we'll look into it. And so the antivirus does not detect it anymore. So this is an allegedly a virus which is now undetectable for the antivirus basis. Simple, isn't it? Everything else we can delete it if we want, and we can work with this one. That could be a potential virus that can be detectable or not. Then we have virus total site. This is a website. There's some 60 antivirus companies, and we want to know which antivirus detects us or not. We can go to the website, upload the file, and see which one is detecting it and which one is not. This is just a crypto that you can download for several websites. Virus total site. Very interesting site for virus development. So signature, desktop, and let's run it. Red ones are seen as a virus, so 8 out of 29, 16 out of 60. But there are many antivirus software that cannot detect this as a virus. Had we not changed that with the crypto, it would have been seen as a virus. All right? So there are many antivirus such as Sophos, Symantec, Panda, Palo Alto, McAfee, Kaspersky, and a series of antivirus that you all know. 95% of the antivirus used at home, or the companies AVG, Avast we know as well. So what we've managed is to build a alleged virus, and it's now undetectable. We've only changed the signature. To see the signature, you just open the hexadecimal editor, and there we have the offset that we got, the output offset that is. This is the hexadecimal file. On the left side, we see the memory address, and this is an offset. If it's a 5, it means increasing 5 addresses in the memory, so 1 by 1. This is the hexadecimal code, and then the ASCII code, which is easily understandable. We've modified part of it to see what part of it. So if we feed it to be compared with other file, let's check this out. We have the signature we've built, and this other one, which is the offset annotator. And here you compare both. Down here you see the differences we've produced. So what you see in green, actually that's what has not been changed, which has been replaced with 0. So it compares both. Okay, let's see this. And these are the differences, and this is the code, and probably this is C4, and there you have it, and it's been replaced with a double O. With that slight change in the signature, this was the antivirus signature, the Avast one, here on this side of the memory, and we managed to alter it so that it is undetectable but executable, though, because these two, the characters that are hexadecimal characters, are not important for the functioning of the virus. We have thousands of apps, lammer apps. It just runs on Windows and easily done. This one I really like for showing commands on Windows because it has so many options, even gateways and DOS attack potential. And there's one for a batch file for Windows. So here we have several options, and on the right side we see how we would run it on Windows using commands. So if it's a txt that we save as a .bat instead of txt, we can see the virus and we can learn from that. So this is the desktop icons. If we want to shut down the device or disable, turn off the internet, we need to copy paste it on clipboard, and we can add it to a text file with a simple notepad. And we can save the extension as .bat. So we call it virus.bat. Or anything that can be done by our systems. Let's see rats next. As when they become more known, they're easily detectable, so we need to be up to date with the different rats and pages that we have available, such as undetectable in Spanish. That's the name of the name. And so what can we do? So in order not to catch a potential rat that anyone can use without the knowledge, they usually change the EOF or the beginning of the file. So with the file, we can see the code for any file which seems to be executable. So it can be a .rar, and that's the offset. Anything we need to change is the start, the beginning. On the editor, we say whatever they say. Or also the EOF, or the end of the code, and indicate the hexadecimal characters. I will not save it. The stop concept that I explained before. We need to have a file where we can fit it, encrypt it, and then expand it inside the victim. Very common that we find with every rat, so that they work regular way. When we open an NG rat, for example, we need a port to work on. So we can state anyone that is not usually used on a computer. Depending on whether it's home or a business, there are different kinds of ports that we need to keep in mind, so there is no conflict with other apps that are running at the same time. I'll choose port 700. That's the address. And then we click build. This is a builder. So we need the IP address that will be tapping. So we have public and private IP addresses. Since I'm doing this on the same network and all the virtual machines are connected, I will use the local IP, the one that we all have at home, but we have a public IP that has been allocated by the internet provider. But we have the non-IP domain as well, which allocates a domain. That's what we need to state towards the IP that is ours. But since the public IP can be changed on the router that you've been given by the provider, you set up a domain that we've registered with a user email and a password. So the traffic is sent to us, and we can be listening in or sniffing the potential victims. So this is an internal network to make sure that I do not infect the host computer. This is IP config, so that I'm not making a mistake later on. Yes, number 5. Yeah, this is our public IP. And then my sniffing port. This is the victim's name. We can call it a victim or call it whatever you want. This is just a description, because if several of them are infected, we will be able to know which one is which. It will be run in a directory. You have here several on the drop-down menu, but we need to use a directory where we have privileges. So when the user is running it, they need to have privileges. And then the name of the exe file, explorer.exe, that's for Windows. That's a process that shows the icons on the desktop. And just like that, we click it and we have explorer.exe as a file. I move it to the desktop, and that's our rat infected. So that's our client, because it's a client server app for proper communication, as we can have with TeamViewer. In order to share it, I have to infect it. We can use a builder, I'll show that in a minute, but we also need to crypt it so that it's undetected by antivirus. I send it to the other machine, to the victim. And I will run it. Nothing will happen because there's just a connection. That's why binders are so important. You need to bind a file. So if I download WinRAR or any file on a website and on the background we have this infected, it'll be properly installed, and then on the background we will have this virus. So on the server now, and I see the victim is already on. And just like this, I have full control of the server. And I just sent a file that is available on the internet. And with the right click, we have the file manager. And we can see what's on the desktop. We have the Explorer. We also have the SH connection program. We can move around the hard drive. We can even delete files by just clicking on delete. And we have so many options. Here we have the remote shell, so we can go in through commands and run commands on the victim. So have access to the record and send voice commands and get control of the microphone or get the passwords that we cache on a website. So remember or save the password. Well, Chrome has a lower safety and security than Internet Explorer, but actually we cannot get that with most of the browsers. We can have a link or the disk or the drive or whatever, and we have the remote connection option where we see on screen what the user is doing. Yeah. If I modify something and I change the icon, even if it takes a bit longer, it should show up. It is, well, I guess this is just a connectivity problem. It's not refreshing. But if you get it on, connected, it should move around and we see what the user is doing. We can also see the webcam and see what's being recorded by the webcam. It is disabled, so we will not be able to see anything. But then we have the key logger. The key logger, as I said, is an app whether if I enter something on the keyboard, I'll see it. If the victim does, I'll see it. So all I have to do is keep refreshing. Very dark, you might not see it, but that's the file I've opened, that's the text, and even the keystrokes. This is an interesting application to see the credentials. If they are going into a website and maybe they don't know what the password is, well, they will enter the password and we will see that real time. We also have DOS attacks or opening a chat that can always be interesting. There we will have a bi-directional communication with the victim, but the victim will never be able to shut it down. This is bi-directional communication and this is real time. Again, the victim will not be able to minimize or shut down the chat unless we say so. So we keep total control. We can delete files, download personal files, anything is doable. We have a command shell, so no problem in doing whatever we want with the victim. See another one? There are many. We have some of them that are very popular, but the more popular, the easier it will be for an antivirus to detect it. So this is 8.8, another antivirus. But this is a port. This is the one default one. Even if you don't see it on the screen, and the builder does the same. We need to have the IP sniffing But we need to install. Might choose not to have it on temp, and then the name we want. It can be server.exe. We can change that, and it is very interesting. One was persistence. The virus, the malware can stay there whenever the computer is rebooting. So it is persistent there. It doesn't go away. We can mask the installation if we want to. We have several options. And then we have the icon. We can change the icon. So apparently it looks like an app, whatever the app we said it was. Let's choose a PowerPoint, PDF then. And then the builder. This is a way of hiding a file inside another file. I will add what I have here on the desktop from CyberCamp. And I will then choose Create Server. Accepted, it says. And in the file 888, we have an exif file where I will manage to infect any victim, then move it to the shared folder. I can send it to the victim or upload it on an FTP or on a website for downloading, etc. If I run it, it opens the PowerPoint. And so this is total control of the victim. So these are the connections, and the victim is on, and with NJ-RAT, same options, even more. This is quite a powerful one, many options for attacking the victim. Here we have the system admin. We can go to the desktop, keep refreshing, it takes a bit longish, and SSH, press delete, refresh, and in a little while it'll be gone. Takes a bit long.
Has eliminado. Bueno, vamos a seguir.
We can keep going. Here we have the desktop capture. It's a screenshot.
Conecto el puerto y se me debería quedar a la escucha.
I connect the port. It should look like it's listening, which it is. Let's see if we can do it. This is real time, so we can see what the victim's doing real time. Let's see what we've got for webcam capture. Logically, if it's ready by default, then we'll be listening to anything and everything that's happening close to the computer. We have the same thing for Chrome or Firefox, but never for Edge or for Internet Explorer. To process admin, we have the console, the dashboard, took a little while, but it did it. And here we have ipconfig. Here we can use Windows commands. There it is. So we can have access to IP addresses and all sorts. We can browse. Let's have a look at the directory to see where it is. Here we have it. We can see we're connected. We see the operative system. We can download files, copy them, generate an FTP file to upload and download files, all sorts. Apart from CMD, we also have online logger, which is one of the most powerful tools in a RAT, because the main objective of any attacker is having access to credentials, whether it's for social media, email, banks, and this is what we can see here, and it's all real time. Here it is. Let's erase that log. I'll close it. What else do we have? We have the chat. It's exactly the same functionality we saw earlier. And it will just depend on how we close the connection. Sorry. I say hello. The victim will see it. They'll be able to answer, but they won't be able to close the chat unless they stop the process. We have the process names here. For instance, explorer.exe. Let's see how we generate the processes depending what we call our virus. There's SV host exe. A lot of people don't know what that is. Because that type of process is quite common. If you see on Explorer something in capital letters instead of small letters, that can look a bit obvious, right? So there it is, closed. You see, we can erase cookies to see Outlook, or rather erase Outlook, to open a CD-ROM, to access the GeoIP location, all sorts. It's going a little bit slower than normal. That's the trouble with virtual machines. I would advise you never to use the host team. Use a virtual machine, because most of those files on the internet are infected. So if you don't have a very good antivirus, it's best to use a virtual machine. Another interesting application is Risk Hacker. Sometimes people look for ways of cracking games, for instance, or applications, and this is how you can get the icon for an application. On the hexadecimal code, I can access the structure of the tree, and we'll have to be careful where we save it, because it's going to generate a lot of files, including signatures. I save it. Come on, you can do it. Let's try that again.
Documentos no. Bueno. Le pongo un nombre.
I'm going to name it. So, we can now see the different icons used by the application, some of them larger. And which one do we need? This one here, the icon for the application. You see, in a game, we would have an icon, we would simulate, but really it's a rat, which is the icon for the game. Sometimes people don't realize. Most of you would have Avast, Kaspersky, AVG. Anybody has anything else? McAfee? Oh, one, two. Just a couple of people have a different antivirus.
Hablar un poquito con lo que es Windows. Esta máquina la voy a cerrar.
So let's stop that a minute with Windows. I'm going to close my virtual machine.
Bueno, vamos a guardar en estado.
Save it. And now with Linux. Sometimes people are a little bit reluctant to use Linux at the beginning because we're used to Windows, right? How many people, if you can raise your hand, use Linux regularly? Well, quite a lot of people. Good. Those of you who didn't raise your hand, well, a lot of things run on Linux. The router at home, your mobile phone. Sometimes we're told that it's really hard to learn, but in fact it's an operating system which is much better than Windows, for instance, as far as the desktop is concerned. Computers run much better. We make the most of the hardware, and you can't do that with Windows. You've probably heard of Kali Linux. which has been really popular. In the past, the version was based on Ubuntu. And Kali is based on Deviant. For instance, there was Mr. Robot, those creatures, you know, the icon with the dragon, for instance. Well, that reminds us of TV series, right? So I've got here my list of practical exercises for us to work on with Linux. You can see it better than with Windows, right? Up on the screen. Can you read that code? I can't see it very well close by here. The letter size is really big, but it's so that you can see it properly from the back of the room. Vale. So, Shelter project allows to open an XN file, so we can modify it and add a virus or whatever. You then close it, and it's then like a builder. You can execute it. I installed it earlier, so it would be ready. I have the shelter file here, and then you can download anything from Windows. An X8 doesn't work on Linux. Linux works with other types of files, for instance, shell scripting. So I'm going to use an emulator, a window emulator called Wine for Linux, so we can execute those files on Linux. This is the one I want, shelter.exe, that Wine. This is from the Shelter project site. You could download this. For instance, H for help. You can also work manually, but we're going to be working automatically this time. Here we have the pen target. I don't need to add the root here. On Linux, you just need to indicate the root for that P target. So I'm going to add the file name, this one here, that WinRAR, so I can then infect it. I paste it, and it's beginning to process it. Even if it says there's an error, just ignore it. It's going to modify the WinRAR code so that I can then modify it and add whatever I want to the WinRAR. All right, the screen is too small. It's because it's a huge letter type. Now it's better, yeah? You can see it now. That's saying the library has been successfully created. Good. It takes a little bit longer. That's why I got the WinRAR, because it's a small file. If it's a larger program, then it would take longer. It's saying whether I want to enable the stealth mode. For instance, in this case, I need to say yes. And Kali Linux has something really interesting. It has exploits and payloads so that connections will make it look like the victim is asking me for connections. Because if I have a firewall, when I try and access a victim, the firewall is going to try and stop me. But if the victim makes the request, then the firewall is going to think it's okay. I'm talking about the normal Windows firewall. Here we have a meta-exploit framework. That's a set of applications ready for pen testing, whether it's ethical pen testing or not. I'm going to get one of these lists. C for custom would allow you to make your own for those of you who can do programming so that the customer would make the connection. And here is saying I should select the index, that is the number of payload I want. This one's pretty well known. Meterpreter, that gives us total control. It allows us to have all permits. So if it's a web server, an internet server, we might want this HTTPS. If it's with encryption, it would be a different one. There's reverse, there's the blind one, but I'm going to go for the most simple option in this case. And here we have some parameters that we need whenever we use an exploit. Set L host means the IP for the local host. That means I would be using my private IP, but if I wanted to get these applications from the internet, I would use my public IP .com or .es, and then I would need to redirect on the router the ports selected so that the incoming and outgoing traffic would come to the internal Kali Linux. Because otherwise, when a request comes from outside, the router wouldn't know where to send it. So I just need to connect internal traffic with external traffic, which is something that's done by a protocol automatically, where we have two networks, for instance, with different ranges. Then a table is generated where my request from my system would then go to the internet, and when I get the response to my request, it would know which internal IP address it should be delivered to. So in my case, I've got 192.168.10. I can't remember what the IP is. Let's make it big for you to see. It's ifconfig for Linux. And what about my IP? Is the one that ends in a 6 here. .6. Good. So this is the port. You can choose any port as long as, well, the recommendation is that it's over 1024, because those are the standard ones for other applications. I often say it's best to go over 10,000 to avoid conflicts. If you don't know, ports are like gateways where applications go in and out of a computer. For instance, port 80 on a website without HTTPS. The request is sent for port 80, and then your computer generates a socket, sends you to a different port so that you can continue to receive requests. Otherwise, I would be on google.com and nobody else would be able to access that website. So applications are always associated to a particular port. I'm going to add here any old port, 700 for instance. And here is the WinRAR generated with a shell with an interpreter. I press intro. ls-l would give us the same WinRAR, but infected in this case. I would then send this to the victim. Let's do that. It's on downloads now. Good. I'm going to copy it, if it lets me copy it, and move it to my shared file that I generated so that all my virtual machines can share things. I go back to the victim, that is Windows in this case, and then I move WinRAR to the dashboard. That's done. And now I need to tell Kali Linux, the attacker, to please listen to me on port 700 with the IP I gave to it. So I use meta-exploit framework. I quite like that one because it's not overly complex. It looks complex at the beginning, but really it's the same commands time and time again. In this case, I have 1,829 exploits, that is scripts, to attack particular vulnerabilities. We have payloads that will be helpful for post-exploiting. Then we have these cryptors for encryption. And this is the problem, right? Because meta-exploit is very popular, so antivirus programs, cryptotypes will detect them quite easily. And here we need to make a difference between null operations, that is gaps that the program skips on NOPs. And then there's a system to evade or avoid the security system. I opened the port, and now with meta-exploit, we're going to use a payload that is multi-handler in this case. What does that do? Well, it gets Kali to listen. Then we need to add the exploit we selected to infect our victim. Reverse XTP in this case. In this case, the command is set, so it would be set payload. And for the directory, you could run a search for a meterpreter, reverse low dash TCP. That is telling Kali Linux to start listening through a payload which is the reverse TCP. Here you should always add the options to be configured for our exploit to work correctly. Here we can see the different names for configurations that should be added, which ones are required. In this case, all three are required. This one is configured. This one is by default quadruple 4, which is the normal one for meta-exploit. If I see 4,444, that port, then I would know I'm being attacked, so we'd better change that. Set L port first, and adding the port that we indicated earlier, in this case 700. Something very important here is adding something that was not down here, which is the L host that will be listening. Because we configured that earlier, we need to go set L host and add the IP address, in this case 192.168.306. So now show options. And you can see how information has been altered. That means the payload can start listening to receive requests, not just for the infected windows that we selected, but from hundreds and thousands of victims, in theory, here. Meta-exploit, and this is where it's now listening to reverse TCP. When I run WinRAR now, it asks for premises, it tells me to install it. So it looks like a normal WinRAR, right? But look how the prompt has changed. It says meterpreter. It doesn't recognize it because it's Linux. But if I type directory, you see I have the executable file, the Explorer. I can go back on the list of directories as far as I like. And if I type there I can see Windows, user, all those files. I can now modify users and access things. For instance, in this case, I've got a user called user. So I can then access the desktop. Let's see what it is. So I access the desktop. And if I type ls, I can see anything and everything on that desktop. I've got all those privileges. I can do anything I like, and I'm listening. Other commands can help us scale up our privileges. That is, for instance, a root user. For instance, get wire. No, get UID, sorry. That will tell me which user I'm working with. Or for instance, I can use get system. I've got their user, administrator, and now get privs for accessing privileges. I would have all privileges for that machine. Commands are quite limited, and you just have to use the same old ones, basically a short list, to have control to the system, to the device. What about commands? Well, let's have a background to go back. There are a number of commands, for instance, sessions -L. That gives me the list of all the victims that I have access to who are connected. In this case, just the one. Look, it gives me that IP, the port, and this is the ID for the victim. I would have session, and I could access it, and the interpreter would allow me to access that victim where I left it last time I accessed the victim. So, what would happen if I install this and press accept? It says ready, fine. I've got my WinRAR. I can now zip, unzip with WinRAR. That's good. But look at that. The connection's gone. Why is that? Because it's not persistent. You need to strive for persistence. You can't let somebody install a program and then tell it to be persistent. You need to keep pushing for persistence. Let's type session -L, and that tells me there are no active connections, because as soon as WinRAR has finished working, then it goes. So how can we manage persistence? There are a number of ways. We can use different applications because we are on meta exploit. I'm going to use one that tends to work pretty well. It's like a post-exploitation tool. It's on the Windows directory. Okay, manage. Oh, it doesn't seem to like it very much. Oh dear, it failed. This is the one. The trouble was that I didn't type it in properly, I think. So if you don't know where it is, you erase it, you type use, you look for it with a dir. The prompt changed. That means that I'm using a post exploit for persistence. And really, the system is very similar every time. Show options. We can see the ones that are required, where it says yes for required. We need those. And this one's really important, is the startup, where we need to indicate which user. Here it just says user. It might be a user without privileges, the user of the machine that we attacked. Here we have to add startup, and then one of these here. I personally like system, because then we can run the processes without any trouble. Says it's ready, and for res name, well, default.exe is there by default, but let's do reset name there. And depending whether it's a known victim or not, we can add here avast.exe or whatever for the process name, so that it's not really obvious. And the path is required as well, because that's void. It has no information. Here we should give information where the WinRAR is with the infected file. In my case, is root, downloads, shelter, winrar.exe. So now with show options, we can check and see that the post exploit has been configured correctly. So now we have persistence. If WinRAR finish installing the application, we won't need to wait for it to finish and then rush and do everything quickly. So exploits, we have a number of tools that are very handy depending what we need to do. I also wanted to show you something. I have this command already to show you, and this is for signatures. I'm going to make the letter type a little bit smaller so you can see it all. This is an antivirus. It's open source, participatory antivirus program, so anybody who can help is most welcome. Is Clan AV that allows to access signatures for Trojans that have been detected. For instance, here we can see that is a Trojan with a hexadecimal signature. So when we find a signature for a virus, we need to go to that code with the hexadecimal code, and all it takes is changing a character. For instance, if there is a 6, having a 7 instead. Well, the antivirus program won't detect it anymore as a signature after I do that.
Más grande. No tanto. Vale, existen luego lo que son las puertas traseras.
Then we have backdoors. And we have so many applications depending on what we want to do or how we want to do it. There's this one that I have preset on Kali that is Weebly, that allows for a backdoor on a web server. So with Weebly, we have several options. It's quite simple. If I want, so let me use this command here. So just with Weebly, we choose generate. As a password, we can choose anything we want. Victims, let's say victim, and the path where we want it. The path, sorry, where we want it. We can set an index or a website or an info.php. And so it's been generated. That's to prove that we are not a robot for things that can be potentially dangerous. There are several commands. Let me share the ones that I think are the most important ones. So this is simple, and we all know how to run a search, right? So green cow, for example, it will look for 2 words, look up 2 words, green and cow. Then we can use it in between inverted commas, and that would be the exact match. So the 2 words in the same order. So it's found it. Same here. Other characters that are very interesting. Let's say that I want to remove Facebook using the minus sign, minus Facebook, and so we have set tags, but those that have Facebook in the content. So we really can fine tune our search. But file type, where we can say whether we want a given file type, TXT or PDF. We search for that. We try and find sites that are just TXT, whatever they are. And so the TXT bots help here. So if I don't want the bots, I can remove that. And so we can remove those bots. So those bots are what are important. I'll say that here, this is what we care about. We want to use site, and it would be colon Microsoft.com. That's for the site search. That's the site where we want to look up. We will look up just inside the content of a site that is as wide as Microsoft.com. Link as well. So sites with links to whatever site we state. Then these are the one in title. That is good. In title of, index of, index of, in case you don't know, it says security breach, where you can see what's inside a directory. They should have been removed of any web server, and we can search around without the link. So there's information that might look as if it's not linked, but we could still gain access. PGP, depending on the site, if it's a repository, this can be interesting. In URL, so it has to be within the name of the website, the address. Let's say password. So we find TXT files which have password as part of the URL name. This is quite dangerous, so I will not open it because probably we'll find some passwords in there, and I'm not authorized to open it anyway. But try it if you wish. You probably will find so many sites with the users and the passwords, even the admin password or the route of the different servers on the internet. So there you can automate the search. That's what's Google Door. That's a way to find a specific vulnerability. This is a serious one, where you can find thousands of passwords with just a prompt, as simple as that. It is quite a breach, security breach. We have so many other options. If interested, we have plenty of information available on the internet on Google Hacking. So if I infect it with this file and then turn it into a .bat, and I'll explain that. Try to move it onto the victim. All right. Save it as, so desktop, save it as the same file .bat. Name doesn't matter. Close it. Close this shell, and then share file. All right. So this is command. So I copy. This is a 32-bit So they should be turned into a 64 because I'm using Windows 7 machines that are 64-bit machines. And so this is shared SF, the shared folder. So I should have it. So it have to be run, and I need to have it sniffing. So yes, intro, and Kali would be listening and would be sniffing. So run, and that's the code. So the framework meta exploit still starting. Now sniffing, not before now, but now it is. Well, sessions. So this is what I was saying. This is a 32-bit file, so we need to use a 64-bit PowerShell for a 64-bit system. I would say use the 64-bit right away because the 32 bits are not being produced unless there are other computers or devices which are not home computers or servers. You need to use a 64-bit. So other options we have as part of Kali Linux as well. MSF, Meta Exploit Framework. Let's use an encoder. This is a practical example. So -B in Windows. This is the interpreter. Where is the -B now? Oh. Reverse TCP. So that is the TCP, the reverse TCP we want inside, and we'll say localhost. And this is the sniffing IP. And the L port as well. And so this is another option, very interesting one. -E, that will link what we have. We can have something of our own with the path, or we can use meta-exploits. But the meta-exploits are very widely used or way too popular. So we rather use a crypto that we've downloaded from the internet, or rather produce a new one. Not so difficult. You've all used cryptos. For example, when you get a WinRAR and add a password, that's what you're doing. You're encrypting the contents of the WinRAR. So it's not complicated at all. There are so many. So there are many, but we need to see. There's a famous one. Maybe way to exploit it, which is Shikara Naui Ganu. Shikara Ganui. -I. 5, those are the number of rounds, so it will be 5 encryption rounds. We can state whatever we want. Then the output, -F as an extension. I would like a .exe, and we're redirecting on Linux to a specific file. So we can say virus.exe. These will be encrypting it 5 times. All L or L has failed, it says. All right. On validation. Well, parameters are all right because these are Linuxes. No, it seems okay. Okay. It might be a virtual machine problem, or there is an interpreter that I'm missing, or the reverse TCP, or maybe I've mistyped a directory, but it all looks all right. I think it's the same TCP address as after the blackout sniffing here.
Vale, sí, tengo conectividad por lo menos. Y la IP es correcta.
The IP address is the right one. I'll leave it here because let me warn you that when practicing, at least my students complain that VirtualBox is an open source app. It's great because it's 100% open source, but sometimes it works, sometimes it doesn't, and it's not up to you. Maybe the same ISO with Kali Linux or any other operating system, and it'll fail though. Sometimes it will, sometimes it won't. If you've used VirtualBox as a virtual machine, you know what's going on there, and it happens. Just a warning. Well, we only have 10 minutes left. This has been just a shallow introduction. I knew there would be some high school students, some people could not make it into the room, but I'd like to promote cybersecurity. That was the goal here. So if there are questions, comments, I'll clarify anything. No questions? Edo? Sure. We are afraid we are not getting the sound in the booth. This is all a local network, as if I were at home attacking myself at home. Logically, I have a fixed IP. Okay, let me get out of here. This one's open. So Linux is different. Windows, I will not explain that, because more or less you all know how to set up a fixed IP. But here you see the interface, which is the loop back, and then I have ETH0. So it's another way to set it up. This is a command interface, which is easier than if I use Linux, and it works way better, much better than the desktop environment. So I have the gateway here, and well, I set not for an output, and so that you can have internet connection. It's a way of increasing security. But this IP, I have it same as you have it at home. This is public. It's an RFC 1819, which is an international standard stating the local IPs we can have. If I want to do it all on the outside, I need to get my public IP. For example, what's my IP.com? You can see which one it is, and that's the one I have to work with. Whenever I have my machine listening or sniffing with lhost, I would choose the public one. But if it's 443, whatever that is, it doesn't matter. When I get the request from the attacker, the router will know what machine it is, whether it's Kali, Windows 7 or Windows 10, etc. So we need to use a port. This one here is 444 Metaxploit, whatever, that no one else is using on my network. So there's a path into my router's firewall, and every traffic on that port is directed to the attacker's IP. But that changes every month or several months. The public IP is not that often, right? So you can buy a public IP using a non-IP domain. You just log in for free. You're given a name, .the domain, .the IP, and whatever the extension is, and you redirect it to your router. So you have access to your router with the website password, and usually they have the IP option. That's where you need to state what's your domain, that it's a unique one. The email address for the login, and that domain will be the one searched for instead of the public IP. So if you change your public IP, it doesn't matter. You will always get the requests. Do you follow? Any more questions? When we enter the sniffing IP, we can state the domain, right? yes, I would choose the address. Well, why am I saying so? Because there are several routes that have the non-IP addresses. 888, for example, you can state an IP or a non-IP domain. Metasploit, I would not recommend it. I would recommend the local IP, right? So that then when you redirected on your router, you use the non-IP domain on the router, because even if you have the non-IP domain internally, when the router finds a request, it won't know where to send it, what internal machine, so you just need a path. So specific traffic that you're interested in needs to reach Kali Linux or the attacker's machine, which is RAT or Windows or whatever. Okay? Any more questions? All right. All right. So you explain how I can attack someone, right? Send an attack on someone, but what if I've been attacked and I wanted to defend myself against what kind of an attack? For example, they were checking my screen. Windows, I presume, yes. Well, there's several commands that can be useful here. For example, let's open a command dashboard. Let's see if I can zoom or pan it out rather. I didn't know this would be the screen we'd be using or the display we'd be using. And I thought there would be more people with their own computers since this was a seminar, but it doesn't matter. We have the netstat command and many options available. -aon, where you see connections going on. So you need to see what your internal address is. This computer here, and the port, the output port. So this is the external IP and the output port. So if this is 80 and there's no browser, something suspicious is going on. So this is port 700, another IP address, and I have nothing open there. I'm not sending a request to that port. So the best way is monitoring. What other options? A paid antivirus, I would recommend that. I'm all for open source, but I think the only piece of software for which I've paid has been an antivirus. Only piece of software for which I've paid. So we need to have software, fireware, and well control and logic security measures, and then not opening files from a non-secure site. I know that because I've tried. For downloading these RATs, I had to infect my virtual machine so many times over. And it is visible. You see it with netstat, and you see every port it opens, IP addresses, all of it. So be careful. It's about awareness raising. Any more questions? No? Back there? All right then. That's been all for me. If there are no questions, that's nice. Thank you.
Vale, una cosa así importante, bueno, estaba la...
By the way, you have my presentation available, and I'm always there. I'm Javier.Blanco. Well, you have that on the PPT, and if you need me, if you have questions, if you want my files or virtual machines, whatever you need, let me know. No problem there. Thank you.